Hi everyone, welcome to Geeks for Geeks practice. Yeah, sorry for the delay. There were some technical issues. Can you just confirm that if I'm audible or not? All right, great. So let's start with today's question. So today we are going to see a question that was recently asked in an interview at Microsoft. Okay, so just a second. Let me share my screen. Yeah. So yeah, am I audible right now? Yeah. Hi Utkarsh. Can you hear me? Am I audible? Okay.
Great. So let me present my screen. Let's start with today's question. Okay, just give me a moment. Great. So let me present my screen. Yeah. So this is the today's question where it says that we need to find middle element in a linked list. Now, who knows the basic of linked list, like who have some idea of the basics of linked list, for them it's an easy question. But again, there are some twists in this question. By twist, what I mean to say is, let's say I have asked you to find the middle element of the linked list. Now, for those who are already familiar with linked list, they might answer that okay, we'll do a traversal till half of the linked list and we will return that particular element. But at times in an interview you are asked to improvise the solution. Okay, so we'll go into the details and all this stuff. It's just that at the starting of today's lecture I just want to make a point that even easy questions can become difficult when you're asked to optimize it. Okay, so let's go back to the whiteboard and let's see okay how things are working. So let me switch to whiteboard because I'll explain the question over there. Okay. So it says that we need to find middle element in a linked list. That's great. Just a second. Yeah. So let's say this is your linked list, okay? Where the first node has the element 1, 2, 3, 4, 5. Now what you need to return? You need to return this 3, right? But before going straight away into the logic and how to do that, it is always good that you read your question fully and notice that if there is any twist or any change that's required in the question. Because I have noticed many times that even questions are easy, student read half of the question and they start away, go on solving this. See why I am saying all this? All these things are not required as far as this question is concerned. I can straight away give you the solution and I can give you the logic also. But my point is that if you're coming here, if you're watching it, then you should also know the mistakes which are usually committed. Okay, so let's start. So given a singly linked list of n nodes, okay, so how does a linked list look like? Like this is my first node, this is my second node, so let's say this is my third node. So the first node stores the address which is at this position of the second node. So this first node points to the second node. This is the place for data. Okay, what is there in the first node? In this case, it's 1, and there is the place for address. Similarly, for second node, it points to third node. The last node points to null because after that we don't have any node, right? So this is a singly linked list of n nodes. In this case, n is 3. The task is to find the middle of the linked list. For example, if given list is 1, 2, 3, 4, 5, then the output should be 3. All right. Why? Because left half contains 1, 2, and right half contains 4, 5. Right. So if I look at it in that way, then my output is 3. What if this is of even length? Like this, in this case, we see that this is of odd length, right? See, we have 5 nodes, odd length. So in the next half of the question, you have the description for even length. So it says if there are even nodes, then there would be 2 middle nodes. That's pretty much correct. Let's say I did not have this 5. Then this is even length, right? 4 nodes. So I have 2 middle nodes. So we need to print the second middle element, right? Second middle element means in this case, this 3. Okay. So we need to print the second middle element. That's fine, not a problem. For example, if a given linked list is 1, 2, 3, 4, 5, 6, so these two are your middle elements and the output should be 4, right? Okay, I hope the question is clear to you. Like what we need to do in case of single middle element, which is in the case when the length of the linked list is odd, and what we need to do in case of two middle elements when the length of the linked list is even, right? So if the question is clear to you, let's proceed forward with the logic, okay? Like how can we develop the logic for this? All right. So let's have a look at it. Okay. Yeah. So let's have a look at it. Let me take a fresh screen for that. So let's say I have this linked list given to me. Okay. Let's say I have this. So over here, my answer should be 3, right? So the very first obvious approach that comes to my mind is that I can straight away calculate the length of the linked list. Okay, I'll traverse once, calculate the length of the linked list. So it will come out to be 5. I do 5 by 2, which comes out to be 2, right? Not 2.5 because it's an integer division. That's how you get it in Java, right? Like it depends language to language. Okay, in Python, you have separate syntax for integer division. But I am talking for in general, like if you divide like this, you will get integer. You'll not get 2.5, you'll get 2, right? So if I do the indexing, suppose I do the indexing, this is at 0th position, this is at first position, and this is at second position, right? So if I do the indexing, I see that I need to return length by 2 element, okay, with respect to the index. Now what will happen in case of even length? Okay. So if I do even length 4 by 2, it's again 2. Same thing will work. Like if this is my 0th place, there's my first place, and there's my second place. I can straight away return this. Why? Because over here I have two middle elements, and if you remember in the question I was asked that I need to return the second middle element, right? So I think this logic will work for both of them. You can do a traversal. Okay, you can do a traversal, calculate the total length, divide the length by 2, initialize a counter by 0. Okay, and you start counting until unless you reach your middle element. Okay, so this is one approach. Now what if the length of the linked list is very huge? Let's say it's very huge. Let's say it's 10 to the power 5. So still you need to traverse like 10 to the power 5 by 2, right? I think we can optimize over this approach, right? I think we can do better than this. Okay, so let's see how can we do that. And before going into that approach, I just want to make a point that it depends on you how you are choosing. Like I have chosen count equals to 0. You can also start the indexing from 1, and you can accordingly have your middle element, right? I see that I am getting 5 by 2 as 2. So if I make this as indexing from 0, I'll reach to here properly. Okay, if I would have taken this indexing from 1, then I would have done something else with the division. Okay, so I hope you get the idea, right? Like over here I have started from 0, hence I'm going till 2, and that's my answer for division also. So think keeping things straight and simple. If you have any doubts, you can ask in the comment section. Okay, so yeah, let's move to the next approach. All right. Yeah. So let me erase this part. So there is a very famous technique, okay, that uses slow and fast pointers. Why I'm saying it's famous? Because if you know this, then you will get multiple questions on linked list where you can use this approach, okay? So let's try to look at that approach. So what we'll do, this is a head of my linked list, right? I'll have a slow pointer pointing to this, and I'll have a fast pointer pointing to this. Okay. The idea is I will make the fast pointer move two steps ahead. Okay. Fast pointer will move two steps ahead, and slow pointer will move only one step. Okay. One step ahead. Now, how will this help? How is this going to help me? So this will basically help in a way that when your fast pointer reaches, let's say, nth length, your slow pointer is at n by 2, right? I hope you're able to get the idea. So what you're doing basically is, with the help of your fast pointer that is moving very quickly, you are able to track where your slow pointer is, and you finally return the element which is pointed by the slow pointer when your fast pointer has traversed your linked list. Okay, I told a lot of things in very short span of time. So let me do the dry run and explain it to you. Okay, so let's see. So initially my fast pointer is over here, right? So what I'll do, I'll make sure that my fast pointer moves two step ahead and my slow pointer moves one step ahead. Now you might have a question that why am I moving this without checking? Like I need to check, right, whether I have element after that or not. So don't worry, when we'll see the code, we'll obviously check. Those things are very much required, otherwise your code will break. Okay. So fast comes over here, slow is over here, right? Now after that, what I'll do, I'll move my fast from here to this position, right? Now my fast is over here and my slow comes to over here. Now I see that I have reached end of my linked list because this dot next is null. Okay, I don't have anything over here. So I'll straight away return what is there in the slow dot data. Okay. Let's try to do the same thing on a even length linked list. Okay, so let's do it. 1, 2, 3, and 4. Again, I'll do the same thing. We have fast over here and we have slow over here. Right. Let's increase or rather change the fast pointer by length 2 and slow pointer by length 1. Okay. So my slow is over here and my fast is over here. Right. My slow is over here and fast is over here. Now we know that we cannot go this far, right? Because over here we have null. Or rather, even if I'm going, this should be my last, last call for fast. Like I should write a loop in such a way for traversal that I should break out after I reach this point, right? So we'll generalize in the code. Don't worry about that. So what I'm trying to say is I'll make my fast point to null over here, okay, after this. And my slow moves from here to this position, right? So we can return this because our fast has reached the end of the linked list. Over here, we returned at this position. But when we look at the code, we'll see that we are ensuring that we have reached either this, okay, fast dot next, which is equals to null. Okay, we'll check if fast dot next equals to null, then there is no point doing fast dot next, right? This will throw a null pointer exception. What do I mean when I say next? It means if this is a linked list, okay, I have named this position as data, okay, and this position is next, which stores the address for the next element. Okay, it is storing the address for this particular node. All right. So see, I know that I have explained this odd and even length logic with the help of slow and fast. There might be few doubts which we will see when we go through the code. Okay, so let's see like how we can generalize all these things in the code. Okay, so let's go to the code straight away and let's have a look at it. Okay, so yeah, let me just see if you have any questions in the comment section. Okay, no problem. So what we should do, let's go back to our Geeks for Geeks practice portal. So here you go. So we have a method get middle, okay, which in which head is passed. So if I take this 1, 2, 3, 4, 5, okay, let's say if I take this, now what's going to happen? Initially, as I said, my slow is over here, my fast is also over here. I'm denoting my slow by S and fast by F. Okay, let me write this because otherwise I'll fall short of space. So fast I'm taking as F. Okay. So what I'm checking, while my fast not equals to null and fast dot next not equals to null. This ampersand is very crucial. You cannot write or over here. Why? Because if you know the concept of short circuiting, what happens is if your first condition, if it is false, okay, if it is false, then you have and over here. Okay, the compiler will not go and check for this condition because what does and says, if both of them are true, then only give me true, right? If first is itself false, there is no need to check the second one, and this is how compiler works. So if fast is not equals to null, if this is true, then only we are going to the second condition. That's why I said this. That's why I said that this ampersand is playing a very important role. Okay, so let's have a look at it. So initially I have my fast not equals to null because fast is pointing to this. Fast dot next is also not equals to null. Why? Because it is pointing to this two. So what we are doing, we are moving our slow from here to here. Okay, slow equals to slow dot next, and fast from fast dot next dot next. So it is coming to this three, like because fast dot next is two, and again two dot next is three, right? So this is how it is. After this, what has happened? Let me redraw. So my slow is here, my slow is here, fast is here, right? Now what is happening is I'm again checking, is my fast not equals to null? That's true. Fast is not equals to null because it is pointing to 3. Fast dot next is also not equals to null because it is pointing to 4, right? Great, no problem. So what I can do is I can straight away increment my slow equals to slow dot next. So my slow comes over here. This is not the scenario for slow now. And my fast equals to fast dot next dot next. Basically, it will go from 3 to 5, right? Now here you will understand the generalization which I was talking about. I know that I did not clear this entirely while explaining the logic, hence I'm doing it over here. We see fast is not equals to null. That's great. After that, what we are seeing? Fast dot next not equals to null. All right, but this is false because fast dot next is null, right? So we are not at all going inside this loop and we are straight away returning slow dot data, right? So this 3 is returned. Great. We have got our answer. Let's do the same thing for an even length linked list. Okay, let's take 1, 2, 3, 4. Now what will happen? Let's see. So initially your slow is here, your fast is here. You check fast is not equals to null, fast dot next, that is 2, is also not equals to null. That's great, hence you go inside. Now you do slow equals to slow dot next, so your slow comes over here, right? Fast equals to fast dot next goes over here, right? Great. Let me erase this portion. Now you need to focus what is going to happen. You check fast not equals to null. That's great. 3 is not equals to null. Fast dot next is also not equals to null. So what you do? You come inside because fast dot next is 4, right? You go inside and you make slow point to here, and fast now points to this null, right? This null is pointed by fast. So if I clear this null is pointed by here. Now if you go again and check, is fast not equals to null? This is itself becoming false, right? Because fast is null. That's the reason you are not at all going to go inside this loop and you are going to return slow dot data, that is second middle element, right? So this is how we are generalizing. I hope now you got an idea what I was talking, like how to generalize in case of even and odd length, right? So I have showed you the dry run for odd length as well as even length, how short circuiting is helping us over here, how we are keeping a check on the fast pointer, okay, and a node just next to the fast pointer, like how we are keeping a check on the node pointed by the fast pointer and node pointed by just next to the fast pointer, right? So this is one of the good approaches that help you determine the middle element of linked list. All right. So I hope this logic is clear to you. Like if you have any doubts in this logic, you can ask in the comment section. Yeah. Yeah. Please let me know if you have any doubts on this particular question. Okay. As I see that we don't have any comments till now. Okay. Now let me refresh. Yeah. So I'll just sum up like what we did today. Like let me go to the whiteboard for that. Just a second. Yeah. We saw two approaches, right? The very first approach, two approaches. First approach was to traverse the entire half of linked list, right? And how you were doing that? This was done after calculating the length. Okay, after calculating the length. So in order to calculate the length, anyways, you are traversing full linked list first. So this is your full traversal. And after that, once you have the length, you are traversing half of the linked list, right? So yeah. What was my second approach? My second approach was that I'll keep a fast and slow pointer. I don't need to calculate the length. Why to do full traversal? I don't need to calculate the length. This step is totally omitted out. Okay. I'll just keep a fast and slow pointer. And with the help of these two, I'll be able to find the middle element, be it in case of, be it in case of even length or odd length, right? And if you want, like I have just now showed you how things are working. So yeah, this is how it is. So today, like this is it for this question. Okay, we have not traversed fully to calculate the length in this approach, which is there on the screen right now. We are just smartly using slow and fast pointers in order to find our middle element. So this was the sum up. Okay, like if you have any questions now, you can please ask. Otherwise, I will just as I do in my every live lesson, I'll just give crux for these question and we'll have our live session end today. Okay, let me check if you have any comments. Yeah, so to get these kind of logics, what you need to do is you need to practice. Obviously, practice is there, but as I said in the very beginning of today's lecture, these are some of the very famous approaches like to tackle linked list questions the slow and fast pointer is one of the famous approach. You will get to know with practice. Like when you are submitting it on online portals, you might get time limit exceeded in the beginning if you're traversing full linked list. Then you can also come up with some better idea other than the slow and fast pointer. Okay, or else like after practicing you realize that what is the need to traverse it fully. Okay, you come up with this approach. So yeah, as I mentioned, like this is one of the famous approach which you will get to know with practice, and if you can do better than this, then you can also yourself like do this piece of code. Like I am saying in terms of if you're in an interview, then coming up with these kind of approaches is not always easy. You must have done some questions in past where you have used these kind of approaches. So this question was asked by Yuvraj, I guess. All right. So yeah, are there any more questions? Okay. All right. So as I see that I'm not getting any more questions. So I think this is it for today. Yeah. Okay, Yuvraj. So I hope this is clear. Great. So see this question. Let me compile. Okay. Okay. So Utkarsh is asking, can we have any other approach? See, this there is one more approach where you are using a counter and you are using properly your middle pointer. Okay, basically that approach it will take more time. Okay, so just a second. There is one more approach as far as I remember. It is there on our blog of Geeks for Geeks. You can watch it. Okay, I mostly go with this approach. So as of now, either we need to spend more time or like you can have a look at it and you can ask in the comment section. Okay, but yeah, I am very sure that there is one more approach. So as you can see, we get the correct answer for this. And why I discuss this approach is because this approach will be required in more questions like detecting loop in a linked list. Okay. There also you can use fast and slow pointers. So I try to take those approaches where this kind of approaches will help you in more number of questions. Like in my last live lesson, I took an approach of stack of finding next greater elements on it, right? Why I took that stack approach? Because that will solve 4 or 5 questions for you, like next greater element to its right, next greater elements to its left. Okay, and next smaller elements to its right, next smaller elements to its left. So that's the reason I have taken this approach. But yeah, as Utkarsh has asked, like you can surely have a look at it and let me know in the comment section. Yeah, Utkarsh, please ask. So I see that you have typed, I have one more question, can you help me? Yeah, sure. Okay. Hi Utkarsh, are you typing something? Because I don't see any question further from your end. Linked list, sort with it in middle. Can you describe it more? Like I did not get your question properly. Linked list, sort with in middle. Okay, you're sending me the link. See, what I'll suggest, Utkarsh, is that there is a live lesson. You can comment down the link. Okay, I will reply back in detail with that particular link. Okay, I'll reply back in detail from our channel. Okay, and if you have any further doubts, I make sure that I reply to it properly. And in the next live lesson, that is on maybe anyways Wednesday, I'll be back live. Tomorrow, hopefully, I'll be there. But Wednesday for sure. If required and you are online, I'll take that question. Okay, if it is not clear from the comment section, because taking a link from you right now in this live lesson, I think I'm presenting my whole screen, right? So I think that is not adequate. So that is one thing. So please comment it down. Please comment it down, that particular link. Okay, and I will reply back. And if you have any doubts, we can take that particular question from that link in my next live session. Okay. Yeah, sure, Utkarsh. Okay. Okay, welcome. So that's it for today. Okay. So if you have any more questions related to this approach, you can ask. And yeah, there is one more approach, as I said, using counter. You can have a look at it. If you have any doubts in that, you can come live, means come in my live lesson in the next class, and you can ask from there also. No issues. Fine. So yeah, and you can surely comment down the link. I'll reply back. No issues. So that's it. This was recently asked in an interview at Microsoft, and as I said, these kind of questions are easy but trickier at times when the interviewer asks you to improvise the solution. Okay. So yeah, and why I discuss this approach is just because this approach will help you in multiple questions. You can also have a look in detecting loop in a linked list. Okay. So I have a comment from Swalika. Hi Swalika. Yeah. So जावा में मैं समझाता हूँ, otherwise other than this sometimes I take it in C++ also. So if you want, like, we can do both in Java and C++. Okay, so let me know that. Yeah, Utkarsh, the stream of timing of next stream is between 3 to 4 p.m. Okay, Wednesday for sure. There will be, I'll be there. To Tuesday, that is tomorrow, like, we need to plan. Okay, so like my current schedule as per my calendar. Okay. So Wednesday for sure, I'm coming up with one more recently asked question in a product-based company between 3 to 4 p.m. You can ask at that particular time. Yeah. Okay. So any more questions, guys? And see, Shalika, I will tell that code you can code in any language in the sense you can code it in Python, Java, C++, because more or less logic remains same, syntax varies, right? So if you want, like, then I can show you codes in C++ also. Like in my initial some of the live lessons, I have showed code in both of them, C++ and Java. If you go to our channel and watch the playlist, okay, so it's not a big deal, right? We can do it, no problem. If you have any doubts related to any other language in the sense either C++ or Java, you can ask in the comments. Okay. Yeah. Okay. Yeah, thank you, Utkarsh, for such a kind comment. Okay, guys, I'll just wait for 1 or 2 more minutes, or if questions are there, I'll be there, no problem. All right. Yeah, welcome, Swarika. Okay, then, see, I would just like to end this with what you need to understand when a question comes to you. First of all, take every question, even if you have done it before, as fresh as possible. Like why I'm saying as fresh, because interviewer also knows that this question is from a lot of one of the famous questions. So he might twist and turn a bit, and he or she will get to know that you are trying to memorize what you have already done. Okay, so take that question freshly. Like in this question, I can give you an example. What would have happened is, as we saw in the even length linked list, right, that we need to return the second element. What if the interviewer has changed the question and would have told you that in an even length linked list, you need to return the first middle element instead of second middle element, right? So these things you need to understand, that if there are odd and even length, where means in case of even length, in this question it was asked to return the second middle element, but these things might change, right? So yeah, so don't take any question so lightly. And yeah, this is one of the questions where it was a good improvisation, right? Instead of finding first middle element, I was asked to find second middle element in even length, and in odd length, I got the exact middle element, right? Okay, great. And Swalika, I would like to tell one more thing, that we have channels like Geeks for Geeks C, CPP, okay, where you can have a look at C, C++ concepts. We have channel Geeks for Geeks Python. We have Geeks for Geeks Java as well. Okay, so from there you can learn languages, and over here we are trying to accommodate good questions, okay, that are recently asked in product based companies, and I try to make sure that I develop your thinking rather than straight away giving you the solution. Okay, so yeah, this was it for today. Thank you guys, thank you for joining Geeks for Geeks practice.